Example 3. Here we want to look at a particular example, testing mu sigma known. Sunspots have been observed for many centuries. Records of sunspots from ancient Persian and Chinese astronomers go back thousands of years. Some archaeologists think sunspot activity may somehow be related to prolonged periods of drought in the southwestern United States. Let x be a random variable representing the average number of sunspots observed in a 4-week period. A random sample of 40 such periods from Spanish colonial times gave us the following data. Okay, so here are the average number of sunspots. Okay, so x is a random variable. So note, we don't know whether x is normal. Fortunately, our sample size is 40. Okay, now the sample mean is approximately 47. So what did they do? They added all these numbers and divided by 40, total number of numbers. Okay, so that is the mean for the sample. That comes to about 47. Previous studies of sunspot activity during this period indicate that sigma is 35. So they are telling us sigma is known, it's 35. It is thought that for thousands of years, the mean number of sunspots per 4-week period was about 41. So this is what was thought. Now, we received 47. Sunspot activity above this level may or may not be linked to gradual climate change. Do the data indicate that the mean sunspot activity during the Spanish colonial period was higher than 41? Use level of significance alpha 0.05. So, first step, establish the null and alternate hypotheses. Since we do not know whether the average sunspot activity during the Spanish colonial period was higher than the long-term average of mu equals 41. Okay, so mu equals 41, that is the null hypothesis. And alternate is mu greater than 41. So greater than, so this is going to be right tail. Okay, all right. Second, B part. What distribution do we use? Compute the test statistic from the sample data. Notice our sample size is 40, which is greater than 30, and we know sigma, so we use the standard normal distribution. We have x bar to be 47, sigma to be 35, mu to be 41, and n to be 40. Using all that, you can get your standard normal distribution. So calculate all of that to get approximately 1.08. Find the p-value of the test statistic. Now we are talking about greater than, so it is a right tail. We have a right-tailed test. The p-value is the area to the right of 1.08. The p-value, that is the probability z is greater than 1.08, it's approximately 0.1401. How do you find this? Using your table. Now conclude. Now, what is the p-value? It is 0.1401, which is greater than the alpha, right? So p-value is greater than alpha, we do not reject H0. So how do we interpret something like this? Interpret the results in the context of the problem. At the 5% level of significance, the evidence is not sufficient to reject H0. That's what we say. We cannot say we accept H0. We say that the evidence is not sufficient to reject H0. Based on the sample data, we do not think the average sunspot activity during the Spanish colonial period was higher than the long-term mean. All right. Now here is part 2, testing mu when sigma is unknown. Okay. Sigma is unknown. In many real world situations, you have only a random sample of data values. In addition, you may have some limited information about the probability distribution for your data values. Can you still test mu under these circumstances? In most cases, the answer is yes. So how do we approach? How to test mu when sigma is unknown? First, requirements. Let x be a random variable appropriate to your application. Obtain a simple random sample of size n of x values from which you compute the sample mean x bar and the sample standard deviation s. You see, you don't have sigma anymore, but you can find the sample standard deviation s. If you can assume that x has a normal distribution or simply mound-shaped and symmetric distribution, then any sample size n will work. If you don't have that, then use a sample size of at least 30. Now, in the context, so here are the 5 steps. First, state the null and alternate hypotheses. Set the level of level of significance alpha. That is step 1. Step 2, use your x bar, use your s, that is the sample standard deviation, and use n, that is the sample size, and mu from h0 to compute the sample test statistic. That is t x bar minus mu the whole over s over square root n with degrees of freedom df n minus 1. So now you are going to use student's t distribution. So notice when sigma is not known, you would use student's t distribution. And the type of test, either one-tailed, two-tailed, or to find or estimate basically the p-value corresponding to the test statistic. Conclude the test. If p-value is less equals alpha, then reject h0. If p-value is greater than alpha, then do not reject h0. That is the null hypothesis. Interpret your conclusion in the context of this application. Okay, so you are going to use your table for students' t distribution to find critical values TC. So you see, let's look at our t distribution. Okay, here is the students' t distribution. All right, so let's see what they are saying. You see one-tailed area, two-tailed area. All right. We find p-values in the rows headed by one-tail area and two-tail area, depending on whether we have a one-tail or two-tail test. If the test statistic t for the sample statistic x bar is negative, look up the p-value for the corresponding positive value. That is, look up for p-value for absolute value t. So no matter if x bar is negative, look up positive. Okay. In table 4, areas are given in one tail beyond positive t on the right or negative t on the left, and in two tails beyond plus or minus t. Okay. So let's look at this. Here you have one tail and you have two tail. So notice how you have one tail. So you are basically getting the right area, the left area. And two tail, you are getting the split. All right. So notice that in each column, two-tail area is twice the one-tail area. Consequently, we use one-tail areas as endpoints of the interval containing the p-value. This will be clearer if we look at some examples, concrete examples, we will see in a short while. Okay, so just familiarize yourself with. So this is use one tail area to estimate p-value for left tail test. That's here. Use one tail area to estimate p-value for the right tail test. And that's a split. Use two-tail area to estimate p-value for two-tail tests. Example 4 shows how to use table 4. Okay, so let's come to this example in our next videos.